Hello everyone, myself Harshit Naveen. So let's implement and prototype a 4x4 multiplier using Quartus Prime IP generator. So in order to do that, let's open the Quartus Prime. Once it's open, we need to open a new project. Open a new project, go to File, New Project Wizard. Next, here we need to assign the working directory. I have assigned the working directory and even the name of the project. Let's go for the next step. So here it has to be the default, it has to be empty project. Then let's go to next step. Next. So here this is the crucial stage, as because we have to select a proper device, and the device which we are using is, so the device is 5CSEMA5F31C6. So after selecting the device, let's go to the next step. Next, and finish. Now the project has been created. Now let's go to the IP catalog over here under the library, and under the basic function you need to open the arithmetic. If you scroll down, you will get the multiplier IP. So here you need to give the file name. So I'll be giving the file name as the same as the project name. Once it's done, let's go for the next. So the IP variation file type will be Verilog. If you guys are familiar with VHDL, you can always select the VHDL. Now over here, since we are doing a 4x4 bit multiplier, here we need to change the from 8 to 4 bit. So once you change to 8 to 4 bit, here you can see that the result bits is also changed, since we have selected the automatically calculated the bit width. So over here, the multiply data A input by data B input, we are doing like A into B. So once it's done, then you can always change the bit to, if you're doing on a 8x8, just select 8 into 8. If it is 16x16, 16 and 16, then here automatically the result will be updated, since we are selecting the automatically calculate the width. Next. So over here we need to leave the default settings. Then over here we can always make sure we can optimize our design either by speed or area. It is default for us. You can always optimize based upon your requirements. For this demo, we're gonna keep it default. So when you come to the next page, you have to make sure you're gonna click the generate netlist, then go to next, and in this page you have to select Quartus prime symbol file and instantiation template file. We should not, if your guys are using VHDL, you have to select the VHDL component declaration file instead of the Verilog HDL black box file. Since I am using Verilog, I selected the Verilog HDL black box file. Once it's done, let's finish. So once the IP is generated, here you can see the files. This is the .v file of the 4x4 multiplier. 4 output result is 8. Now let's compile this. Once compilation is done, we need to go and we need to run the IO assignment analysis. Once you compile this part, later on you have to go to the assignment and pin planner. So here we have to assign our datas and the results to the pins and the LEDs on the FPGA board. To assign the pins and the LEDs of the board, we need to refer to the data sheet, and this is our data sheet of assigning the LEDs and the switches. So I have assigned the input pins to the switches and the output to the LEDs based upon referring the data sheet. Once it's done, you have to close this window. Then don't forget you need to add the clock file, which is this is the STC file, as we know how to add this clock file from the previous videos. Once after assigning the plane, you need to again compile the design. Once the compilation is done, let's program the device. Since I have programmed it previously, I'm just selecting this device, then start. You all can see that it has been successfully programmed. Now let's see the demo how the FPGA board works. So in this board I have assigned the initial first 4 switches to the input as A and the end 4 switches to as the input B, and the output will be displayed on the results. Since it is a 4x4 multiplier, we will be displaying the 8 LEDs. So I'll just show you a demo. If I turn on all the input switches, you can see the LEDs have turned on. So all input just turned on. If we convert to the decimal, it will be 15 cross 15. This output is 225. So over here you can see that it is 1, it is 32, 64 and 128. If to add all the decimal values, you will get 255. Now I have switched to the 4 cross 2. So it's 8 in decimal, it's 8. So if we convert the bit, so you can see the only one is turned on. To take a look into this, we will consider this as the LEDs. So 1 2 3 4 5 6 7 8 LEDs. Or it's 4 cross 4. This LED 8 would turn. Another example by turning on 8 bit. So we should get 64. 64 is turned on. 64 is turned on because input is 8 into 8 is 64. Understand by seeing the simulation of this 4x4 multiplier. This is a simulation of the 4x4 multiplier. Here you can clearly see that the values are input as in a hexadecimal value. You can see that 2 into 3 is 6. So if you compare with in the decimal, it is always 2 3s are 6, 4 7s are 28, 5 9s are 45, 8 is 64 and 15 225. So E1, 40, 2D, 1C and 06 are the hexadecimal value. This is a table. So input A and input A and the corresponding values. So from this we can conclude that the simulation is working properly. So remember, if you guys are simulating the IP generator, you need to compile this. File which is 2 and 222 model. You will find this .v file in the, so you will find this 222 model .v file in this location C Intel FPGA 222 Quartus CDS SimLab. So you have to copy this file and place it in your current working directory folder. So whenever you have to run the simulation of an IP generator, you have to make sure before compiling the test bench, compile this 222 model because it contains all the IP model defined in it. Since I compiled the 222 model.b file, you can see all the IPs included in the Quartus prime have been generated. So once you compile, then again you have to go and complete expense file. Once it's done, you will get the waveform. This is how you will verify the focus for multiplier. Thank you.